Hello students, in this video we'll see an example of how to evaluate an infinite product. Let's consider the product, k goes from 1 to infinity, of 1 plus 1 over k plus 1 times k plus 3. Now we know that this infinite product will converge. This is going to converges since the sum k goes from 1 to infinity of 1 over k plus 1, k plus 3 converges. We recall that an infinite product of the form 1 plus an converges if and only if the sum from 1 to infinity of just the an converge, and that's this exact term over here. So this product will converge, and now let's simplify this product to see what we can get. So let's look at the partial product. So Pn is the partial product, and that's going to be the product k goes from 1 to n of 1 plus 1 over k plus 1, k plus 3. And of course we can combine these terms over here to be the product k goes from 1 up to n. And then I'm going to have a k plus 1, k plus 3, and then a plus 1 over k plus 1, k plus 3. So if we simplify this product, what will we get? We're going to have in the numerator, this is going to be k goes from 1 up to n. I'm going to have a k squared, and then we're going to have a 4k plus 4k plus a 4 over k plus 1, and then k plus 3. The top is just k plus 2 quantity squared, so this partial product is just the product k goes from 1 up to n of k plus 2 times k plus 2, all divided by what? All divided by k plus 1 times k plus 3. And so let's write out what this is going to be. So how many things are we going to have up here? Well, the top is going to start at 3 times 3, right? So the top is going to be a 3, then it's going to be a 4, then it's going to be a 5, and it's going to go all the way up to what? The last one we're going to get is going to be an n, and I have that quantity squared times. And the bottom is going to be what? The bottom is going to start at what? This term over here is going to start at a 2, and it's going to go all the way up to n plus 1. And then this term on the bottom over here is going to start at a what? Start at a 4, and go all the way up to what? An n plus n plus 3. N plus 3 over here. Good. All right, and so what's going to happen over here? So let's analyze this carefully over here. So what's going to happen over here? Maybe we'll write a few more terms just to get our feet wet. So we're going to have a 3, 4, 5, 6, 7, 8, all the way down to n plus 2 quantity squared. And the bottom over here, we're going to have a 2, 3, 4, 5, 6, all the way up to an n plus 1. And then over here, we're going to have a what? A 4, 5, 6, 7, 8, all the way down to n plus 3. Great. Okay. Well, let's see what's going to cancel. Lots of things are going to cancel over here. So first, notice that there's going to be a 1 extra 3 on top. There's only 1 3 on the bottom over here, right? And there's 2 3s on top. So what's going to happen is, let's start with those cancellations. So the first cancellation I'm going to get is the following. I'm going to have a 1 3 on top. Then notice that all the 4s on top are going to cancel. I have 2 4s on top, and I have 2 4s on the bottom. I have 2 5s on top. I have 2 5s on the bottom. So 5s are going to cancel. And then, so what's left on the bottom over here is I've canceled out one of the 3s already. All right, so there's a 1 3 on top. There's going to be a 2 on the bottom. And then let's figure out the last terms over here. So then we're going to have what? Well, there's going to be an n plus 1 down over here and an n plus 1 over here. That's going to cancel out. So I have 1 n plus 1 left on top. So I'm going to have 1 n plus 1 left on top. That will be canceled out by this thing over here. So that's actually gone. So that n plus 1 is actually gone. So let's eliminate that guy. So that's going to be gone. And then, so let's see what happens on the bottom. So that n plus 1 is going to cancel out with that top n plus 1. There's also an n plus 1 over here that cancels that n plus 1. So the top is going to have a what? The top has 2 n plus 2s. One of them will cancel out with this n plus 2 over here. So I'm left with a what? A cumulative factor of an n plus 2 on top, because that second n plus 2 wasn't canceled in this first set of terms. It was only canceled down over here in the second grouping of terms. And then what's left on the bottom? So I have an n plus 2 left on top, and then what on the bottom? An n plus 3 left on the bottom. So that gives us a formula for our Pn. So this implies that Pn, our nth partial product, is just 3/2, and then n plus 2 over what? N plus 2 over n plus 3. And then this, as n goes to infinity, converges to P infinity, and P infinity is going to be just what? Just 3/2. And so we can conclude from this that the product, n goes from 1 to infinity, of 1 plus 1 over n plus 1, n plus 3, converges, and in fact it's a telescopic product, it converges to 3/2. Thank you very much.